Okay, I will start the webinar now. Welcome to our monthly forest restoration talks. Webinar series that is organized jointly by the Superb Project and the IUFRO Task Force Transforming Forest Landscapes for Future Climates and Human Well-Being. And today we actually plan to have two speakers, but Kirsten Tonicke from the PIC Institute for Climate Impact Research had to cancel on a very late notice because of personal reasons. But we're very glad to still have Marco Patacca as a presenter today. And today we will focus on forest resources and disturbance projections and implications for biodiversity restoration. Next slide, please. Some housekeeping rules. This webinar is being recorded, and the recording will afterwards be available to watch on the EFI YouTube account and on the IUFRO website. For questions to the panelists, please use the dedicated Q&A box. After the presentation of Marco, we will promote selected participants to speakers so that you can ask your questions yourself if you are interested. Otherwise, we will read them out for you. And if you want to tweet about the webinar, please tag us using either at IUFRO or at Superb Project. I'm very happy also to have two co-moderators today, Elisabeth Schatzdorfer, who is the Superb Project Coordinator, and Andreas Bolte, who is coordinating the IUFRO Task Force. And now I'm happy to introduce Marco. He is a PhD researcher at Wageningen University and Research. And his research focuses on forest functional ecology, on climate-smart forest management, on European forest disturbances. Of course, we will talk about that today as well, and on forest resilience. And now I'm happy to hand over to Marco. Please share your screen. And you have the floor. Looking forward to an inspiring presentation.
Thank you, Gesche. Thanks for the kind introduction. Can you see my screen?
Yes, we can. Thank you.
Okay. Thanks a lot, and thanks everyone to join. Today I will talk about specifically fire disturbances in Europe and how climate impacts the wildfire regimes that is affecting European forests. And we will talk about a bit about the past and how things historically developed regarding fire regimes in Europe. And then we will have a peek into the future projections and what does that mean for restoration. So first, a little bit of an overview of the past trends of fire disturbance in European forests. So this picture that you see is a time series of fire damage on European forest growing stock expressed in million cubic meters per year. And I will go through the picture and dissect it a bit in order to reflect on the trends. Well, as you can see, in the 50s and after the war, fire regimes were quite stable, and the main policy back then used to be fire suppression. So because people were living a lot in rural areas and using a lot forest environment for resource gathering and so on, fire was perceived as a very negative thing and as a threat, and therefore all the effort was allocated in suppressing fire. But this, as a result, caused an accumulation of fuel loads in the forest floors, and by the end of the 60s, there were some shifts in socio-economic and demographic trends. So, well, people start to use gas much more instead than fuel woods, and people move to cities, abandoning rural areas more. So there was a lot of fuel loads in the forest, and the threat was not so much perceived anymore in rural areas, as a lot of people moved to urban environments, and this caused an increase in fire damage and also in burn area throughout the 70s and 80s. Then at the end of the 80s, what happened is that, especially in Southern Europe, where a lot of fires happen because of the Mediterranean environment, some management and have been start to put in place, both prevention management, which includes, for instance, prescribed burning, and also promptness of intervention. So people were much more able to spot wildfire in time and act quickly. So this led to a decrease in burn area and also in fire damage as a consequence. However, as you can see in the last part of the time series, there are a lot of peaks of fire damage. And if we look at this with this extra panel on the bottom, which represents the climate anomalies from the 50s to 2020, as the same timeline of the graph above, we can see that the, let's say, unfolding changes in climate switch or shift the fire regime. And this was indeed the first sign of a shift in regimes, where even though the burn area and the damage was initially in the 90s going down, few very big fires took the scene and caused a lot of damage. Now, there is a lot of research, of course, on wildfire, and there is a quite established correlation between aridity and fire size. And I refer here to this work referred on the bottom of the slide from Mark Grunig. Actually, take the pointer. And with unfolding climate change and increasing temperature, of course, also aridity is expected to increase. And as well as the probability of having these very big fires. An example that was also visible in the previous slides was the wildfire in Portugal in 2017. And this very large, impactful fire has been defined by the media and the press as mega fire. But yeah, so this is a bit how the regime shifted in the last 20 years, moving from a lot of small fires to few very big fires. And then, of course, given, well, this relationship between fire size and burn area and environmental aspects are used to model the behaviors of fire into the future. Behind these modeling exercises, most of the time, global climate models are used to, let's say, use the prediction of how climate will become in different CO2 concentration pathway scenarios. However, there are a lot of global climate models that are used to predict climate trajectories. And as you can see in this panel, so each cross is a different model. They behave quite differently. And they predict quite of a wide range of alternative scenarios of climate change. And this, of course, creates a lot of uncertainty. What we did is that we selected two of those models that take into account 65% of the ensemble variation of these climate projections. and using the relationship that been previously described between fire characteristics and an environment, we try to predict scenarios of burn area into the future. And this is an example of some of this prediction with the two different models and the model mean. But then, of course, as we move into the future and into the unknown, as the title of the slide says, it's also very hard to validate those projections, and especially because behind those scenarios lie the projection of the climate model, and as you can see, there is quite a lot of uncertainty behind it. However, it seems that burn area, and especially the size of the wildfires, is expected to increase. And the question is, how will forests respond to these shifting regimes? Well, as a scientist, my answer is it depends on the forest. As you can see in this picture, so this is a picture I got on the internet. It's a 9-month post-fire forest in the Canary Islands, and this is Pinus canariensis. And as you can see, well, after only 9 months after a wildfire, the forest is right on a recovery trajectory, and the trees are resprouting and coming back. So how the forest will respond? In this sense, forest models are a great tool to explore the future. And in our group and in my work, we use the epicenter space forest resource model to project the state of the forest into the future. And the model, let's say, includes all the knowledge and the data that are available on forest dynamics in Europe. And with this background knowledge, we try to project the state of the forest into the future. And then in this, we also simulate the effect of fire, or how fire would affect the development of the vegetation. And specifically in epicenter space, we model the effect of fire on each tree as a function of the fuel load that is available in the stand and the size of the tree, which determines the percentage of crown killed by the fire. And the percentage of crown, together with some species-specific information, like for instance bark thickness, is used to calculate the probability that that tree will die or not. So this is an example of some simulation, 50-year simulation of the Spanish region of Catalonia that we performed. And here I'm gonna present from now on some literature and some work in progress. So just for your knowledge. So the blue line is a simulation where we didn't simulate an fire impact, and the pink line is a simulation where we simulated 5 impacts from the scenarios I showed before, and from the RCP, so relative concentration pathway 8.5, which is the strongest scenario we did. So as you can see, in 50 years, the difference of the fire impact on those forests is not that wide, and it's about 3.5 cubic meter per hectare, more or less. But then, of course, well, forests in Catalonia are also forests that co-develop with fire. So they are the 3 species that that are in the Mediterranean region have a long history of co-development and co-evoluting with fire, and they have strategies to cope with it, as you saw in the previous picture, their resprouting capacity and so on, and many more strategies. However, there are some evidences from the literature, and I refer now I'm going to refer to the study from Ballet et al., reference on the bottom of the slide, that when we have wildfire in forests that are not historically been exposed a lot to wildfires, the situation might change. So because those forests not being exposed historically to fire are more susceptible to it. And this is a study that analyzed wildfire in 2022 in France, and the difference between the Mediterranean region and the south of France and the temperate region and this Atlantic coast region of France. So as a result of these studies, you can see on this latest panel the impact on the maritime and pine forest plantations in the southwest of France is quite high, and it's about 87 cubic meter per hectare. And if you compare it with the 3.5 cubic meter per hectare damage that I showed that is predicted that we predicted in the previous slide, it's quite a difference, right? And of course, this as climate change unfolds and we expect an increase in wildfire, and also up north and in regions where fire is not historically so much of a problem, that can create some issues. And the reason of this impact is, of course, both because of the species characteristics, but also because of the forest structure, especially, I would say, in this case. So as we move north, here are some pictures from Sweden. So we moved into the northern edge of the temperate biome, which is south of Sweden. And this is a picture from a wildfire of 2018. So as you can see here, 2018 was an incredibly fiery year in Sweden, and there was this record of burn area, I would say, of 25,000 hectares, which is quite a lot, and it caused extensive damage to Swedish forests. Now, as you see this colorful picture with all the different profile of Sweden, this represents the fire weather index. So the which is an index that based on some environmental conditions determine how likely the weather conditions are for a fire to happen and to be sustained. So this was the situation in July of 2018 in Sweden, and as you can see on the right, there is the legend of the fire weather index. So it was sustained for several weeks, and there was in many places what was in 2018 characterized as extremely high fire risk, with a fire weather index of 28. Now, this picture that just popped up, it relates to 2022, so only 4 years after. And as you can see on the scale of the fire weather index, well, the scale had the need of adding quite some more colors. And however, there was not as much damage in 2022 as fire weather index is not enough to cause, or at least it's not enough in one point in time to cause a lot of damage. But given the rapid development and unfolding of changing in climate, we are also moving into an unknown league, and this also refers to what I mentioned earlier with the climate scenarios, that we expect an increase, but we don't really know how much that will be. So as you saw, for regional cases, especially in the south of Europe, it seems that the impact of wildfire is much contained, but specifically in local cases, so at the local scale and in regions that are not used to fire, with forest types that are not used to fire, the damage can be quite huge, as those picture testimony. So now I'm going to introduce you to another graph that comes out of a modeling experiment we did, where we initialized 3 mixed broadleaf forests, one in Spain, one in Germany, and one in Sweden. And we ran a simulation without fire, and imposing in a specific year, where you see the vertical red line, quite of an intense fire, with a fire weather index of 38. And what you see is of course, the different initial condition of those forests, but also the impact that the same fire had on the different forests. And those forests are rather similar. So it's a mixed broadleaf forest. Here's the composition. And in the Spanish and German forest, there are more or less the same main species, at least. Slightly different in South Sweden, but quite similar species composition, I would say, overall. However, the impact, as you can see, can change quite a lot. Now, about biodiversity, of course, the differences in species plays a role in the response of the forest community to fire. And so this is a different modeling experiment that I'm going to introduce you to. It's set in Germany, and we simulated 4 different forest types in Germany with different species composition, which is a bit small, but it's described here on the side. And then in one specific year, we imposed the same strong fire of before. So the purple line is a monoculture of spruce. The blue line is monoculture of Scots pine, Pinus sylvestris. The pink line is the same forest type of before, so it's a mixed broadleaf with beech oak and other accessory species. And the green line is a forest with mainly Scots pine, but also mixed with other broadleaves. And in this case, you see that while the monospecific stands decrease in growth stock, and especially in the comparison between pure Scots pine stand and mixed Scots pine stand, you see that towards the end of the century, there is a shift where a much lower stock stand actually is able to maintain more or less its stock level, while the pure monoculture just goes down. Now, of course, the type of species that are there plays an important role, and this is especially important in the context of restoration. And this is a figure from a very recent work that was published in a Nature journal from Wesley et al. And it's about the suitability of 3 species throughout the century, and which 3 species are continuously suitable throughout the centuries and which don't, and also which will become suitable in different areas at the end of the centuries. And this work also comes with a quite, I think, nice online tool to check in different climate scenarios which species will be suitable throughout the old centuries and where. So I think I put it here because I think it's quite important, especially for practitioner in restoration. So what does some implication or reflection about restoration? Well, we saw that especially related to fire disturbances, but I think this applies also to other disturbances. Behind me, in the picture behind me, there is some wind and bark beetle disturbance combination in the North Tatra in the south of Poland. It's also quite big scale, and I think the shift in disturbance regimes will cause abrupt pulses of disturbances, as you can see on in these pictures on a wide scale, in places and in forest ecosystems that have never really experienced those type of disturbances before. And I think the fact that at a smaller scale these wide disturbances might happen will cause quite some issues in terms of restoration, because, for instance, what has been experienced throughout Europe when this big scale disturbance happen is the lack, for instance, of restoration materials as can be seedling and seeds to restore those ecosystems. And then, of course, as climate change unfolds, and bigger and more fire are expected, this will become more and more of an issue. So this is for cases when, of course, restoration happen. In some cases, perhaps that is not directly needed. Also, that's always something to reflect upon before carrying out restoration practices, I think. Or in other cases, maybe it's needed to carry out restoration for other reasons, and not so much like for re-establishing the vegetation. Like this is picture right after a fire in the south of Europe, and those pine trees, as I showed in previous picture, will be able to resprout most probably, but there might be other risks, like, for instance, soil erosion when there are slopes, or landslide threat to people. And all these conditions are always to be taken into account. And especially, I think this highlights the needs or the fact that each restoration activity, of course, can learn from the wealth of work that is being carried out throughout Europe. And I think Superb is a great example of gathering all this knowledge together, but also needs to consider the specific case and the specific conditions. So this leads me to some few take-home messages out of my presentation. Well, first of all, something that it's good to take into account is that it's difficult to predict the future, especially in terms of disturbances, but surely all the clues are there to expect more wildfire, and especially wildfire outside their historical ranges. So as I said, these pulses of disturbances might have quite of a big impact at the local scale, and the potential to disrupt the forest sector, and also to disrupt all the ecosystem services that forests provide to society. So abrupt large enlarged wildfire might drain the regional availability of restoration material, hampering restoration practices. And this is something that needs to be taken into account also logistically. I think it's good to have it in mind. Biodiversity matters, or in this case, the tree species diversity, I should say, matters. And of course, when carrying out restoration, it's very important to consider the species pool that will need to face the change in environmental conditions that we are expecting into the future. Well, as I said, special restoration efforts are needed in some special case, which always are needs to be evaluated in the specificity of each case. And also something that I didn't really dive into, but well, adaptation, in my opinion, is also a form of restoration, because we know that we will face increased pressure from the changing climate. So better safe than sorry, I would say. And thanks a lot. That's the end of my presentation, and I give it back to Geisha.
Thank you very much, Marco, for this great presentation, also very entertaining. So thanks a lot for that. I'm pretty sure that Elisabeth has a direct response to the adaptation recommendation in your final slide, and then we can start the discussion also with maybe some input from the chat.
Yeah, thanks also from my side, Marco, for this very nice presentation. And indeed, I very much liked your final note on the need for adaptation, because this is exactly also basically the narrative that we follow in the Superb project, where we more often than restoration talk about pre-restoration, which is like combining the restoration thinking and the adaptation thinking, because in a changing world, one doesn't go without the other. And so this actually also leads me to my first question, where and it may be a bit tricky to answer, but still, so these mega fires, or these changing fire regimes, where overall it seems to be getting more and more severe, and also forest systems that so far have not, or maybe to a little extent, been impacted, are now getting more and more impacted. How much do you think fire suppression, which has been kind of abandoned or reduced in the last decades for several reasons, be it on the one hand, people not being there on the land anymore, but also on the other hand, there's a certain notion that, of course, there is also a natural forest fire regime, and if you suppress forest fires completely, you might get more extreme fires than if you would have had allowed for some small-scale fires. So maybe this understanding has also brought people away from too much fire suppression. But how much do you think reintroducing this some sort of fire suppression would be needed in order to avoid maybe some really dramatic system changes of some forest ecosystem types? Because I think if we really see these mega fires, these much more extreme events, we are like at the point where a system change at some point may not be avoidable anymore. So do we avoid this system change by increasing fire suppression, or would you rather suggest to really go directly into the adaptation pathway, and like be this the main tool to maybe avoid abrupt system changes, but maybe go it the less extreme way and do this adaptation?
Yeah, thanks for the question, Elizabeth. Yeah, I mean, I think that well, first of all, I think that we are nowadays very good at spotting fires, especially there is a lot of there have been a lot of resources and the technological developments, especially with, for instance, remote sensing technologies, enabled us to be almost spotting fires in a semi-real time, let's say. And this, of course, allows for a much prompter intervention. And in the meanwhile, like at the same time, there is a lot of knowledge that has been especially developed in the south of Europe in the way of, well, on one side, suppressing fire, so intervening when a wildfire starts. And I think that is also the case that it is still happening and very efficiently. But also there is a lot of knowledge to manage the forest ecosystem in a way that we can reduce the fire risk. And I think this is specifically important, both on a, let's say, wildfire management side. So for instance, as I mentioned, with prescribed burnings or reducing the fuel load and so on, but also on the more forestry side. So with there are different silvicultural measures that can be put in place to reduce that. And regarding the mega fire, I think this I don't really know how I feel about this term, but I think well, it's to make such a big extent fire happen. There is a series of conditions or thresholds that need to be passed, and those thresholds might change depending on where you are in Europe, and they are different also depending on where you are in Europe. And I think, well, definitely, it let fire intervention in terms of suppression might happen, but when you have such a fire, like let's say long-term fire weather conditions, and a lot of fuel in the forest, basically the fire becomes of an intensity where the crews of firefighters that like it's just out of their control, and they just have to wait that the weather condition change in order to be effective. So in that sense, I would put a lot of effort also into the preventive management and adaptation, as been mentioned.
Thank you very much. I know that there's also a question from Andreas, and then we've promoted Diana Abuya as a panelist, so she can ask her question live after Andreas.
Yeah, thank you also, Marco, for this really inspiring and nice talk. I have one question also referring to your take-home messages, and this refers to the, I think the post-fire dynamics. You mentioned that there might be some restriction with planting material after especially also larger fires. But I would also like to ask you about, what do you think is the potential of natural succession? Because we have also, especially also in Germany, the discussion with also some large fires in the last years, and Scots pine dominated areas in eastern Germany, and there's a debate on the role of natural succession, and especially not to replant, but just more or less to leave it to natural succession. So what do you think about this option in a greater extent, for example, on a European scale?
Thanks, Andreas. Well, I think it's a very relevant reflection to make, and actually, there are quite some evidences that such a let's say, wide-scale pulses of disturbances are actually somewhat how can I say that, like boosting the natural succession, which might be a way towards adaptation. So basically, we can do a lot of things, and we should carefully think what to do. But we can also, well, an option among those things is to do nothing and leave it to nature to reestablish itself and develop. I think this option is very valid, and well, it depends also a lot on the socio-ecological system that is around the forest, right? It depends a lot on the ecosystem services that the society is receiving from this forest, that can be both in terms of resources or in terms of, for instance, of regulatory ecosystem services and so on. I mentioned in my talk landslides, for instance, and if you have the risk that after a disturbance on a steep slope, there will be landslides, especially a disturbance like fire, where the biomass is consumed and the soil is exposed. I think then it might cause some threat to perhaps human settlements at the bottom of the valley or things like that. So I think indeed that this is a very important question, and it's very specific to the needs and to the cases, I would say. Yeah, I don't have a silver bullet answer, I'm afraid, but it's very hard, especially to when you reason on such a broad scale, like European scale, to have just a one-shot solution, I would say.
Yeah, we always look for that in forest management, but it's quite region specific. We have a question from Diana, and you can ask it live now.
Hi, thank you. Thank you so much. My name is Diana. I'm a PhD student in Penn State University here in the United States. Thank you, Marco, for your talk. It was nice to know more about fire and your temperate forest. I work in the northeastern deciduous forest here, and I particularly work on a management of an invasive shrub in the understory of this forest. And I am interested in knowing more about the invasion process after a wildfire in a global warming context. Is it like the temperate forest more prone to, or more exposed to be invaded after a wildfire?
Thanks a lot, Diana, for the question. Well, I start saying that I'm not an invasion ecologist expert. So this question lies a bit outside my sphere of expertise, but well,
maybe someone from the panel can respond to this, or has done some research on that. But you can, of course, elaborate on your what your point of view is, Marco.
Yeah. Well, I just maybe briefly. I think it really much depends on. Well, I guess your question was referring more on the post-disturbance processes, right? And I think the issue of invasive species, or species that are introduced in a new environment, it can also play quite an important role in the disturbance happening itself. And we had some examples here in Europe as well. But regarding the post-fire dynamics, I think that certainly when the vegetation gets burned down, then the competition for light and resources that tree species have to put in place kind of gets reduced. So if there is the breeding material, simply seeds available in the surrounding areas of invasive tree species, or tree species that are not endemic of that area, let's say, they certainly could, and if those species are very good at using resources, and that they could certainly establish, that's certainly a possibility. But I'm afraid I cannot. I don't have the knowledge to elaborate further on the ecological processes of those species. But maybe you have an example of your.
Any further comment from the panel?
Well, I think Marco has answered it quite well, and there is also just some limits on how much I can add to this. But certainly the question of what was the species pool before the fire is very relevant. So the question whether non-native tree species might themselves pose a higher forest fire risk is of course relevant. The debate has been, for example, in Portugal, Marco has shown this example on how much the eucalypts has caused actually, or been decisive in the development of these mega fires there, or would have it happened also with different species. But I think there's quite some agreement that at least it did, the species itself did play quite an important role. And then of course also that Marco has said, if you have these light benefiting invasive species somewhere nearby, you certainly will have a change in the system that I would think can be quite dominant then for a long time. So there is certainly a time dimension to this re-establishment process, and whether then in all cases, as Marco explained, the natural succession would really be the perfect way for adaptation, or if you would then actually allow too much of the invasive species to take over is also a question that needs to be evaluated or answered case by case, I think.
Thank you very much, Elisabeth. Andreas, did you also want to comment?
Yeah, perhaps. I guess it depends also on the spreading or distribution type of the species. So because I guess a large disturbance like a large forest fire opens up the space for invasive species which have also like a pioneer character. But I can remember I worked a bit also a few years ago in Sweden, in an area where we had the opportunity to have a long record of vegetation history, of pollen analysis. And it's an interesting point there was that after the glacial period, and that time the beech knocked at the door. So in this case, really, beech was invasive species, and it was in the southern part of Småland. And at that time, the beech was suppressed by frequent forest fires because beech is a late successional species. But then the fire stopped due to also socioeconomic changes. So people were expelled and had other more or less land use activities and slash and burn. And due to this, the beech as a competitive species could invade the area, and then more or less, and in former times there was more Scots pine and oak. So from my side, it depends really a bit also on the ecological type. So if the invasive species is a so-called pioneer tree species, I guess fire may then favor those species.
Diana, it would be great if maybe once you have more research results, you can be in contact with us and maybe have a presentation at this webinar. Just, I think this question is really relevant for the participants as well. So if you have more answers on that, maybe next year, please be in touch.
Yeah,
thanks.
totally. Yeah, I'm working on that, but I'm still in my field season today. Actually, I took a break today to be in this talk, but tomorrow I will be back fighting those shrubs. Yeah.
Okay, so looking forward to hearing from you sometime soon.
Yeah, thank you so much.
We have another question, which I'm not sure if you can answer it, Marco, because I'm not sure if the modeling results say something related to that, but the question is from Rodrigo Munoz, and he asks what regions in Europe are currently at greatest risk of being affected by major wildfires.
Yeah, thanks a lot. Well, I would say that the highest increase in wildfire occurrence is expected into the Mediterranean areas. But I think the question is a bit tricky because, yeah, more flames doesn't necessarily translate into more ashes, and that's exactly what I was trying to point out in my presentation, that, well, Mediterranean forests are since century used to have recurrent fires, and being used to those regimes, perhaps those forests are more resilient to it, and will suffer less damage compared to forests that, well, for instance, temperate forests or even boreal forests. We have seen some fire season that was devastating in Siberia in the past years. Well, those forests are much more densely stocked, and I think provide much more fuel to eventual fire. So I would say that in terms of European region that will witness an increase in fire, it will be the Mediterranean. But the regions that will face an increase in problems or damages caused by fire might be regions that up to date have been less exposed to it.
Thank you, Marco. Elisabeth?
Maybe just very briefly an additional thought on that, and I very much liked your saying, Marco, that more flames do not necessarily lead to more ashes, and this made me really think of also some additional aspect, which is the experience in fighting fires and preventing fires, right? And this is totally differently developed in the different regions and countries. And while Mediterranean forests are certainly on the one hand also more adapted, also there is much more experience in dealing with forest fires. So other countries where this has not been such an issue before will also in this regard struggle much more. And so a smaller fire, what starts as a small fire, maybe may become relatively bigger because people are not that experienced yet in handling it. And therefore it's so important that there is this initiatives for like cross-European learning on how to deal with this issue of forest fires, and that is like forest fire risk facilities are being established and so on. So I think there is very great developments in this regard. So, and I think this needs to be taken a bit into account here, also in like projecting where forest fires may occur more or less in the future.
Thank you, Elisabeth, for your comment. We have actually a couple of questions from an anonymous participant in the chat, which are very general and I think all very relevant, but I don't think we can answer them now in this webinar. But we aim at answering them in the research that Superb is conducting, and I'm also sure that there are some answers in the research that the IUFOR task force is conducting. So stay tuned, we will follow up on them, and I might pick up one of them in the end of the webinar, but I would like to focus on very specific questions to the presentation. So I'm inviting Koen Kramer, who is also working in Superb, to ask his question live. Oh, we can't hear you, unfortunately. Okay. Then we'll be able to see you and I will read your question. I'm sorry. Okay. So your question relates to large-scale forest restoration and the and your expectations, Marco, if this large-scale forest restoration efforts implemented with those efforts, if also large-scale fires will increase, and what we could do to avoid that, if you have an answer to that.
Yes, I think it's a very relevant question, and this is especially relevant in the south of Europe, I think, where there is I don't know, socio-ecological phenomenon of forest abandonment and fragmentation, which very often leads to basically these forests previously managed being abandoned and becoming overstock. And I think I didn't mention it during my presentation very much in depth, but forest structure is also very important in the response of fire. And I think having very densely stocked forests highly increase the chances that if there is ignition of a wildfire, that will spread and in a very intense way. So I think in restoration upscale, this is an aspect that might play a very important role, and that it should be taken into account very much. So, for instance, thinking about the densities of, if we are talking about planting, or also the management of those restoration projects, you know, like very, well, restoration doesn't necessarily mean only planting trees, but also looking after them. And yeah, I think this kind of things should be always taken into account when upscaling. Yeah, I guess that will be.
Yeah, so you mean it has to be integrated into the restoration planning, basically.
Yeah.
Have fire gaps, or to
Exactly.
to anticipate the fire risk in the restoration planning. Thank you very much. Elisabeth, you also wanted to comment. Thank you.
Just very briefly, because I think this is indeed a super critical issue, because when there is now the proposal and the various indicators for forest restoration, maybe in the framework of the nature restoration legislation, there has been the criticism that the focus on like carbon stocks as being like the more the better is really critical or can be counterproductive, and that it would have been like preferable to have here a much more balanced view with additional guidance on, as you say, yeah, how do you really manage the forest and not bluntly go just for highest carbon stocks possible, because in the end you may really then again lose more carbon than what you have been gaining by any restoration process. So I think this is really a tricky issue. So thanks for the question and also the elaboration on it.
We have another question in the chat coming from Claudio Garone. He's an Italian forestry doctor who's also an expert in forest fires and wildfires. And he's writing that in Italy, unfortunately, more than 95% of forest fires are of culpable origin, but mostly arson. And are there studies and data on any similar situation in other European countries, in case you know of them?
Yes, I think more or less the same shares could be applied throughout Europe, and usually, yeah, the start of a wildfire always, like, it's very high chances that comes from human activities, either voluntary or not. I don't know about that. But I think there is quite a lot of data and statistics that have been collected throughout the last 3 decades, I think, from early 90s, about the origins of fire, or the ignition of fire, and the causes behind it throughout Europe. I think, yeah, there is a well, those materials are available online, and perhaps also the database on forest disturbances could be a good source to navigate this more in depth.
Yes, I absolutely agree. And I will also share the link to the policy brief that you prepared together with other researchers last year. And I think there is also a link to the database in the policy brief. So I will share this in the meeting chat. There is another question which relates to your research scope from Roland Quatain. And he's asking which countries were selected. I think the question is for the research that you conducted.
Yeah, so as I said, our work is a work in progress, but we work at European scale. So I think up to date, we are working with about 17 different countries in Europe. Yeah, I showed an example of 3 countries from 3 different biomes, but yeah, we are conducting this work at European scale.
Excellent. I'm sharing the policy brief now. Then Andreas still wants to ask a question. Please go ahead.
Yes, thank you, Gesche. Unfortunately, fire disturbances are not the only disturbance we are facing now in large parts of Europe. So, you know, I think especially in Germany, we have lost about 500,000 hectares due to a complex of drought and bark beetle attacks and so on. But what do you think about the interaction? Because, for example, Dutch bark beetle attacks, they provide potential surplus of fuel for following fires and so on. And I can remember also a former president who was a fan of reputed reckoning in forests in Finland, more or less to get rid of more or less the fuel. And there might be also some strategies like this, I think, is also in Australia to get more or less the deadwood out of the forest. But on the other hand, deadwood is also a large source of biodiversity and so on. So what do you think about this multiple interactions of disturbances and remnants of disturbances, like deadwood material in the forest and the role for then following fire disturbances?
Thanks, Andreas. Yeah, that's very on point topic, I would say. Well, certainly the interaction of disturbance of different disturbance causes is very relevant, and some of the mechanisms that might happen we are aware of. Some others we might be surprised, as the feedback between climate and disturbances might change with changes in climate. But I think it's certainly like a possibility that deadwood caused, or like caused by other disturbance types might burn down if left there. But I think this also comes back a bit to the question you asked earlier about what to do, living nature to nature, intervening, and so on. I think that it's very difficult to generalize, at least for me, in the sense that it really depends on what's the objective of your intervention, let's say. Certainly deadwood is a crucial component of the carbon cycle, and therefore it's very important also for mitigation purposes. So it's hard to find a trade-off as such a broad scale. Yeah, but definitely something to reflect upon when, and I think basically everyone in Europe is thinking about it, what to do, and but yeah, I'm afraid I don't have a sharp answer once again.
Yeah, that's also a topic that was covered in a podcast that I listened to yesterday, and I think it referred to some studies that were done in the US, and those studies said that the forest who had quite some deadwood, that they did not burn more than the forest who did not have deadwood. I would need to dig out the study, so I can't because I don't remember, but it is already being explored, I think. And if you look at the ecosystem perspective, like the increased biodiversity through the deadwood can also increase the resilience of the forest. So it's we can't find a final answer to that, I'm afraid. But I think also we have to wrap it up now. There are those general questions from the anonymous participants that I noted down, and I promise we will address them in upcoming webinars, so stay tuned. And I would like to thank Marco now a lot for answering all those quite difficult questions, and sharing your really broad knowledge, not just on the forest modeling, but also on everything related to disturbances and ecology. So that was very impressive. Thanks for that. And for keeping us entertained, also with the panel here. And I would like to now ask Gabi to share the final slide, which is basically our best wishes for a very nice summer break. We will reconvene on the 11th of September, and we are still discussing the topics for the autumn phase. We might talk about old growth forests. We might talk about the water cycle in forest. We have a couple of topics that we're still discussing, so stay tuned and have a nice summer break. And thanks also to my great co-moderators. Have a great time and a nice rest of the day. And thank you also for those tuning in from the US and other parts of the world where it's probably night or early morning or very late afternoon. Very much appreciated. And yeah, we will catch up in September.
Thanks a lot.
Yeah, thank you,
Nice day.
Gesche.
Bye
Thank you,
bye.
Marco.
Everyone, bye.
Bye, everyone.
Bye.